IP-20C overview. This module introduces the fiber IP-20C product, its position in Ceragon's portfolio and its main features. The agenda of this module will cover the following topics: evolution of Ceragon radio technology, fiber IP-20 platform, network topologies examples, IP-20C product overview, hardware overview, radio features, Ethernet features, synchronization features, system configurations, IP-20C unique features set and IP-20C radio parameters. The fiber IP-20 platform provides a wide range of configurations to match the requirements of diverse network scenarios. It offers flexibility in choosing all outdoor, split mount and all indoor configurations to suit any deployment scenario. Powered by a software-defined engine and sharing a common operating system, Cera OS, the IP-20 platform delivers ultra-high capacities while supporting any radio transmission technology, and any network topology. As mobile operators look to small cell deployments to extend coverage and boost capacity to meet the growing demand for data mobility, Ceragon offers small cell backhaul solutions that operate cost-effectively today and are remotely expandable to meet tomorrow's needs. Ceragon's fiber IP-20C represents a new generation of radio technology, capable of high bit rates and longer reach, and suitable for diverse deployment scenarios. Fiber IP-20C breaks capacity barriers, offering a virtual fiber solution in licensed frequency bands. Its versatility makes it ideal for a wide variety of cost-effective deployment scenarios including macrocell backhaul, small cell aggregation, and emerging fronthaul applications. IP-20C is easily and quickly deployable compared with fiber, enabling operators to achieve faster time to new revenue streams, lower total cost of ownership, and long-term peace of mind. IP-20C can deliver multi-gigabit per second capacity on a single frequency channel, setting a new standard for efficient spectrum use. IP-20C's unique multi-core radio architecture is based on an advanced parallel radio processing engine, built around Ceragon's in-house chipsets. The result is superior radio performance with reduced power consumption and form factor. The Fiber Series pay-as-you-go activation key model further enables operators to build for the future by adding capacity and functionality over time to meet the needs of network growth without requiring additional hardware. Additionally, IP-20C's multi-core architecture enables operators to start with a single core with the option of enabling the second core remotely when network capacity requirements increase. The 4x4 line-of-sight MIMO feature adds yet another element of scalability, enabling operators to quadruple capability with the addition of a single IP-20C unit and antenna at each end of the link while utilizing the same exact frequency channel without network replanning. Traditional cellular network, or radio access network, RAN, is built with many standalone base stations, BTS. Each BTS covers a small area, while a group BTS can provide coverage over a continuous area. Each BTS processes and transmits its own signal to and from the mobile terminal. A BTS needs its own cooling, backhaul transportation, backup battery and monitoring system and so on. Spectrum resources shared among BTS, where the same frequency or channel will be used by two BTS that are not neighboring or isolated from each other. Traditional cellular systems have important limitations. First, each BTS is costly to build and operate. Although Moore's law helps reduce the size and power of an electrical system, the supporting facilities of BTS are not improved as well. Secondly, when more BTS are added to the system to improve capacity, the interference between BTS is severe as BTS using the same frequency or channel will be close to each other. Thirdly, because mobile users are moving from one place to another and because of the nature burst of mobile data application, the traffic of each BTS is fluctuating very much from time to time, day to day. The average utilization rate of individual BTS is very low. However, these processing resources cannot be shared with other BTS. Thus all the BTS must be designed to handle the maximum traffic expected no matter the size of the average traffic. This causes a lot of waste of processing resources. This is DRAN, distributed RAN, the classical access solution where the radio units and digital units are collocated in the same site. The alternative is CRAN, Cloud RAN, sometimes referred to as centralized RAN. This is a proposed architecture for future cellular networks. It includes DUs implemented separately as a centralized signal processing functionality of RAN. The radio units are connected to the digital units using CPRI, Common Public Radio interfaces over microwave networks. Mobile networks are evolving quickly in terms of coverage, capacity and new features, continuously pushed by new requirements relating to latency, traffic volumes and data rates. By introducing Cloud RAN architectures, operators will be able to meet these accelerating demands through the use of network functions, virtualization techniques and data center processing capabilities in their networks, which allows for resource pooling, scalability, layer interworking and spectral efficiency. A Cloud RAN architecture will therefore exploit a combination of virtualization, centralization and coordination techniques. In the following, you may see typical network topologies examples. The IP-20 family constitutes a single platform serving all radio transport technologies in any topology and any installation configuration. Here are some network topology examples where you may see the common usage of the fiber air products. This is a typical tree network topology. This is a typical ring network topology. Please note that IP-20G is interoperable over the radio link with IP-20N, IP-20GX and IP-20S. Also note that a radio link cannot be established between IP-20C and IP-20N, IP-20C and IP-20S. The same product type has to be at the both ends of the link. In the following slides we will overview the fiber IP-20C product. Fiber IP-20C is the first true multi-core system in the industry which utilizes parallel radio signal processing in a compact, all-outdoor device combining radio, baseband, and carrier Ethernet functionality to offer a future-proof solution for point-to-point connectivity applications. IP-20C supports cutting-edge capacity boosting techniques, such as line-of-sight MIMO, advanced frequency reuse, QPSK to 2048 QAM, and header deduplication, to offer a high-capacity solution for every network topology and every site configuration. Virtual fiber in licensed frequencies, offering 1 gigabit per second radio throughput over a single 28 MHz channel utilizing 4x4 line-of-sight MIMO. Simple operation, by software-defined radio, rapid deployment, and minimal truck rolls. And it is environment-friendly, with compact, all-outdoor unit with low power consumption. A front view of the IP-20C reveals the 2 antenna ports, one for each carrier, where carrier 1 is sitting below. A rear view instead will reveal the TNC source sharing interface, dedicated for MIMO setup, which is the connection between both nodes on the same site, for synchronization of VCO, voltage control oscillator, and reduction of phase noise. And the RSL interface running over BNC connector used for antenna alignment. Finally, a bottom view of the node will reveal, from left to right, the power interface. Ethernet interface 1, which can also serve as power over Ethernet. Ethernet interface 2 of SFP type. The Ethernet interface 3, which can also be configured as data sharing in case you're using MIMO setup. And the management interface running over RJ45 interface. Let's see now the radio features covered by this unique product. It can operate in 6 to 42 GHz frequency range. Its support to channel spacing from 3.5 to 80 MHz channels can go from QPSK to 2048 cam, channel dependent, with hitless adaptive coding and modulation. It also has ICM adaptive power multi-carrier ABCX PIC, cross-polarization interference cancellation MIMO, multiple inputs, multiple outputs AFR, advanced frequency reuse multi-band headed deduplication automatic transmit power control override timer. We'll discuss more about these unique features in this product overview presentation. IP-20C features a service-oriented Ethernet switching fabric that provides a total switching capacity of up to 5 gigabits per second or 3.125 megapackets per second. IP-20C's service-oriented Ethernet paradigm enables operators to configure VLAN definition and translation, class of service, and security per service, service point, and interface level. IP-20C provides personalized and granular quality of service that enables operators to customize traffic management parameters per customer, application, service type, or in any other way that reflects the operator's business and network requirements. Features like quality of service, lag, LLDP, ASP and others are now standard for IP-20C. Fiber IP-20C represents a flexible synchronization solution that enables operators to configure a combination of synchronization techniques based on the operator's network and migration strategy, including PTP optimized transport, supporting IEEE 1588 and NTP, with guaranteed ultra-low packet delay variation and support for ACM and narrow channels. Native sync distribution, for end-to-end distribution using gigabit Ethernet. Sync pipe regenerator mode, providing PRC grade, aka G.811, performance for pipe, regenerator, applications. Fiber IP-20C is designed to support the following site configurations: multi-core 2+0 single or dual polarization, 2x multi-core 2+0 single or dual polarization, multi-core 2+2 single or dual polarization hot standby, 2x2 and 4x4 line of sight MIMO, 1+0, 2+0 or 2+2 space diversity, 1+1 hot standby with space diversity and advanced frequency reuse 1+0. In the following we will present the Fiber IP-20C's unique features set. IP-20C's parallel radio processing engine is what differentiates IP-20C from other multiple-core solutions, which are really nothing more than multiple radio systems compacted into a single box. IP-20C's multi-core architecture enables IP-20C to provide significant improvements in capacity and link distance, as well as low power consumption, smaller antennas, more efficient frequency utilization, less expensive frequency use, and a small form factor. The 4x4 line-of-sight MIMO feature adds yet another element of scalability, enabling operators to quadruple capacity with the addition of a single IP-20C unit and antenna at each end of the link, while utilizing the same exact frequency channel with no network replanning. The figure in this slide illustrates a 4x4 line-of-sight MIMO direct mount configuration. The 4x4 line-of-sight MIMO utilizes two IP-20C units. Each unit uses dual polarization, with all four radio channels using the same frequency. Each unit is connected to an antenna using an OMT mediation device. Advanced frequency reuse, AFR. To thrive in the increasingly competitive, hyper-connected world, network operators must rapidly expand the capacity of their networks by densification, which means effectively adding many new cell sites. AFR works to enable links to achieve high modulations despite adjacent links transmitting at the same frequency and interfering your link. Links that would otherwise be limited to QPSK can work up to 2048 cam. Thus, AFR enables the reuse of frequencies and, also, the establishment of wider channels in much denser deployment scenarios than possible through conventional link spacing parameters. Multiband feature. A growing need for increased network capacity is shared by operators and IP service providers. Multiband bundles E-band and microwave radios in a single group that is shared with an Ethernet interface. This provides an Ethernet link over the radio with capacity of up to 2.5 gigabits per second. A multiband link is highly resilient because the microwave link acts in effect as a backup for the E-band link. In normal circumstances, both links transmit simultaneously, dividing the traffic between them. The maximum capacity of the IP-20C is 1 gigabit per second, with the IP-20E handling the rest of the link's capacity. In the event of radio failure in one device, the other device continues to operate to the extent of its available capacity. Thus, operators benefit from both the high capacity of E-band and the high reliability of microwave. Let's now summarize the features this fantastic equipment has. Multi-core solution, adding a second carrier in one click. Adaptive coding and modulation capable from 4 to 2048 QAM support, going from 6 to 42 GHz, covering bandwidths of up to 80 MHz, supporting advanced radio features like MIMO and advanced frequency reuse, operating as a full carrier Ethernet machine, and last but not the least, equipped with Power over Ethernet interface for flexible deployment scenarios. The agenda of this current module has covered the following topics: Fiber IP-20 platform, network topologies examples, IP-20C product overview, hardware overview, radio features, Ethernet features, sync features, system configurations and IP-20C, unique features set. Thank you for your attention.